Okay, so welcome to this tutorial. So it's number 3. We will do only one example. Okay. The tutorial about proving that the span of a set is a subspace or is even a space. Okay, so this is the question: show that the span of the set S written as one or made of the two elements 1 1 and 1 minus 1 is all of R2. So basically what we are asked to prove is to show that any element in R2 can be written as the linear combination of these two vectors. Okay, so to the answer. So basically, okay, to show that S, the span of S is all of R2 means to show that any element, to show that any element of R2 can or is must be is a linear combination of the two vectors in S. Okay, so that means if we pick any element xy in R2, okay, so if we pick any element xy in R2, that must be equal to the linear combination of the two vectors of the set S. So what we have to do is to find, linear combination of the two vectors. Yeah, it's C1, 1, 1 plus C2, 1 minus 1. So we need to find C1 and C2 such that any vector xy can be written as the linear combination of these two vectors. Is that okay? So now what we have to do here is to do Gauss elimination. So here we have C1 plus C2 equals to X. So we need to find the C1 and C2. C1 minus C2 equals to Y. We add, so let's go with the Gauss's method. But anyway, this is very simple. So let's add these two together. We have let's be consistent. We have static Gauss's method is for a reason, so it's to be used. So let's use Gauss's method. So we have what here? Minus rho 1 plus rho 2 will give C1 plus C2 equals to, sorry, minus C1. No, so it's C1 plus C2. We don't change the rho 1, okay, is equal to X. And okay, minus C1 plus C1 is 0, minus C2 is minus 2. C2 equals to minus X plus Y. So let's do back to substitution. So this is our rho 1, this is going to be our rho 2. So if we pick now, let's do back substitution. Back substitution. if we pick row 2, we have minus 2 C2 equals to minus x plus y. That means C2 is equal to minus x plus y over 2. Okay, so that is our C2. Now let's write down row 1. In row 1 we have C1 plus C2 equals to x. That means C1 is equal to x minus C2 equals to x minus C2 is minus x plus y over 2. This is going to be equal to x plus x over 2 minus x over minus y over 2. Minus y over 2. So this is going to be equal to so that's plus. I hope everything is right. We got C2 C2 is going to be equal to 3x over 2 minus y over 2. So that's going to be C1. So I hope let's make sure that everything is properly written. I see here. Okay, I made a mistake here. So I divide it by minus 2. It should be x minus y. This is x minus y. Okay, so minus, okay, let's see, in here. So here we have to change signs. So we have x minus y, which is x minus x over 2 plus y over 2, so that's x plus y all over 2. So we can say that for each element, for any vector xy in R2, there exists C1 equals to x plus y over 2 and C2 equals to x minus y over 2, such that the vector can be written as the linear combination of the element of S. X, Y. Therefore, okay, S, the subset S is the span. So therefore S spans R2. Or we can just say S is the spanning set of R2. Okay, so this is a short tutorial. We are going to stop here. In summary, to be able to show that a set is a spanning set of a vector space, we need to find the scalars C's such that an element of that space can be written as a linear combination of the vectors of that subset, or that small set we call the spanning set. Is that okay? So see you in the next video. Thanks.